We've officially entered the danger zone as we've moved into our last talk for the day. With us, and you'll notice a slight deviation from our normal SuriCata-centric or focused talks in an effort to continue to support the open source community and other open source and like-minded projects. Jean and Vincent will be talking to you about CERTitude, an open source and agentless compromise assessment tool. Yes.
Thank you.
Okay. Hi, everybody. Thank you for being here today. Like it has been said, we are going to talk to you about some kind of different tool. You will not hear most about SuriCata during this talk, but since there is an open thing trying to integrate new open source projects by the OISF, we thought that it would be a good idea to candidate to be maybe sponsored by the OISF. So here we are today. My name is Jean Marsault. I'm working at Wavestone. I am working inside the CERT Wavestone as the head of R&D. I am the original developer of the tool that we are going to present to you that is called CERTitude. I am also a CTF player. We are currently doing the CTF, so you can find us. And mostly during my work days, I perform penetration tests and incident response.
Hello everyone, so my name is Vincent. I've been in the InfoSec field for about 10 years and I'm now in charge of the incident response team of Wavestone. So we are a commercial response team working for our clients. Wavestone is a consulting firm of more than 3,000 experts and consultants. We do many kinds of consulting such as functional consulting, but obviously we are working in the cybersecurity practice. As Jean said, we work on security audits, penetration tests, incident response, crisis management, and so on. And we have also some different developments in-house. For example, CERTitude. So here is the only one SuriCata that you will find during this presentation. So, why are we here? We are not here to talk about SuriCata, but about another tool. Let's back to some years ago. Actually, as you know, the OISF was built around SuriCata some years ago. Then, about 3 years ago, the French National Cybersecurity Agency, was called ANSSI, joined the OISF to promote French contributions to open source InfoSec projects. And finally, some months ago, the ANSSI presented us to Kelly and the OISF in order to discuss a potential integration of CERTitude within the OISF. So here we are to present you what is CERTitude and see if people can be interested to contribute to this project. But before explaining what is CERTitude, I think the very first thing I need to do is to explain the needs behind this tool. So first need, actually, when we are in incident response, we do forensic analysis, and then, usually, we need to quickly assess the extent of the compromise on the overall information system. This means we need to check each workstation, laptops, servers, and so on, based on the first IOCs that we would have found during the initial forensic analysis. Back then, when we were in our very first incident response, EDR didn't exist, and actually most of our clients haven't deployed such tool yet. So we still need to have this kind of tool to do the assessment of the extent of the compromise. Then, second need, in France, the ANSSI provides some specific IOCs to some companies and asks them to perform IOC search on their information systems. So some companies came to us in order to help them performing this kind of activities. So again, we need a tool to look for IOCs in every kind of information system. Then third need, again in France we have specific InfoSec regulation which gives some guidelines and requirements while performing IOC search, so we need to comply to it also. Last but not least, we want to contribute to all the great work done in the community and especially in the threat intelligence sphere. So we want our tool to be easy to work with tools such MISP, OpenCTI, MITRE-ATT&CK, and so on. So based on all these needs, we started to work on CERTitude back in 2013 with the first approach of CERTitude, which was called Scanopy. Then Jean joined our team and started to work on the very first versions of CERTitude. We continue to develop it and use it during a couple of years, and we faced many scaling issues. So some months ago, we decided to rework CERTitude quite from scratch, and actually we are almost done, but as we have been very busy in incident response lately for some major clients, we don't have published it yet, but it will be done very soon. So enough for the introduction. I'll leave the floor to Jean, who will give you some insight on how using CERTitude, why using CERTitude, and how CERTitude works in its core.
Okay, thank you, Vincent. Before talking about CERTitude, I want to tell you a short story about what an incident response assignment may look like, what we are usually confronted to. Basically, your assignment starts when the victim, usually, for example, a ransomware victim or something like this, they call you and they say, okay, I found a suspicious element on my information system and I want it investigated. So they call you, you arrive on site, you start investigating what you know is compromised, and you start painting a profile of what the attack looks like. This is not only a static profile, but also a kind of behavioral profile. So you will have behavioral elements, in-memory elements only, like, for example, open connections to the C2 of the attacker and things like this. Since you are not searching only for static signatures, you have to search for these elements that rely in memory only, and you would have to scan the whole information system for them. Unfortunately, what you don't have in this assignment, for example, but it happens a lot, is that the logs that you have on the computers, the workstations, they are very sparse. You don't have many information inside of them. Usually they have a short retention time. For example, you have 2 to 3 days of logs, and you want 1 to 3 months. And they are not centralized, so you cannot go back inside in the past to search past logs for the events you would search for. So in this kind of moments, you want something to perform this global search on the information system and to search for these behavioral patterns on the workstations and the servers. And this is why we decided to create CERTitude. So what is CERTitude? The global definition of CERTitude is that it's an automated collection and analysis tool that will gather data from the assets on your information system, and that will analyze this data to search for behavioral elements that correspond to the attack on the information system. Some adjectives that you can give to CERTitude. The first is that it is agentless, at least on Windows. You do not need to have installed an agent on your information system before running CERTitude. So you don't have to, for example, have a contract beforehand with the client when they install your agent like 2 months before an attack, and then you use this agent. It's also a tool that is discrete. You keep the indicator of compromise on hosts that you know that are safe, and you do not disclose them to the potential attacker, and we will dip into that later. And finally, it's respectful of your data. Your data the client data will not leave its information system. It will stay there and it will be analyzed there, so clients who will have sensitive data won't have any problem with your tool being lodged on this information system. So if we recap all of this, you get this, picture. So basically, CERTitude is a tool that you run on the computer that you feed with indicator of compromise, and that will get launched on the information system to gather data, analyze it, and then give back results. However, what CERTitude is not, CERTitude is not a blind threat hunting tool. You cannot just git clone CERTitude, install it, launch it, and expect to have results about every compromise that you have on your information system. Because CERTitude needs to be fed with indicator of compromise, it will need tuning to adapt to the target information system. And of course, like every tool, you will have a small quantity of false positive that you will need to filter. So enough about the basics. Let's raise the hood and see how it works. What we will see during this presentation is that CERTitude operates with 3 different tiers. The first tier is the CERTitude, what we call the master node. Basically, this is your computer that you have with CERTitude installed on it, and it will be the thing that will guide all of the analysis and the collection. You will have to operate on the third tier of CERTitude that corresponds to the client information system, which is composed mainly of workstation servers under Windows and Linux, mainly. However, what you cannot do, and what we wanted to do in the first place but couldn't, was to expect our workstation, our master node, to be able to join, to communicate in terms of network streams with everything in the information system. In most clients, you will have an information system that is widespread, worldwide, and you have zone segregation, and you can't join everybody in the information system. So to solve this issue, we added a second tier to CERTitude, which are called the centralizer nodes. The centralizer nodes will be placed strategically within the network, and their goal will be to be reachable by each part of the network they will address. So, for example, here we have 3 world regions: US, APAC, and EU. And in this configuration, we will have 3 centralizer nodes, 1 for each world region. The centralizer nodes will launch the collection modules on the workstation and servers. They will gather data, analyze it on site, and then send the results back to CERTitude. So how does it work? If we dive into how we can use CERTitude and how you will install it and how you will use it during an assignment, the first thing that you need to do is configure your hunting environment. Basically, you start with only your master server, you install CERTitude, and you need to configure some things. So first, you need to install the master node, and then you will have to configure this master node. Mainly, you will have to add users on the master node, and there will be 3 types of users, at least for now. You will have the administrator, who can manage everything from the master node to the centralizer nodes. You will have the viewer. The viewer will be able to see what happens on the master and on the centralizer. And you will have the basic viewer rights, which will be, for example, given to your client just to access the result dashboard on the master node. What is important to notice is that only the administrator and the users will be able to log in on both nodes. The master node will be available to everybody because this is the reporting node, but all the technical nodes, the centralizers, will not be available to your client. Then, when you have configured this first master node, you need to give IOCs to it. So IOCs are, in general, a collection of small elementary indicators that, for example, target processes, services, registry keys, connections, DNS entries, etc. So what we wanted to do was to take this IOC and to parse it and to split it into these elementary indicators that will facilitate the analysis after. So how does the master node work? We decided to use Python 3, because Python 2 will be out of support soon. Python 3 with a web interface. Its backend is developed in Flask and based on SQL Alchemy. And we have a React.js frontend. And our goal is to support the most number of IOC standards on the market. So for now, the Open IOC, Sticks, even the CSV, if you want to have IOCs in that format. So you take your IOC, you feed them to the master node, and the master node will parse it and split it into elementary indicators. Then so this is what this looks like for now, but it's subject to evolution. So you go to the authentication form, then you log in. When you log in, you can add the users that you want to interact with on the interface. You can create all the centralizer nodes that you will need after. And then you can upload the IOCs that you need on your system, and that will be given to the centralizer nodes. So how does it work after that? So like we said, you may be in a situation where you need multiple centralizer nodes. So you will have to export some kind of configuration file from the master node to initialize all the centralizer nodes. All of them will be identified by a global GYUD and their IP address, and you will feed them the indicator of compromise that you will have enter on the master node to configure the centralizer node. Once you have configured them, you will be able to create a configuration file that corresponds to your centralizer node. In particular, this file will contain all the elements that the workstation, the assets in the client information system, will need to contact the centralizer nodes. The reason behind that is that when we want to collect data on the workstation, the servers, all the assets in the information system, we want to do it using what is called group policy objects. Group policy objects are objects within the Active Directory infrastructure on Windows domains that enable the launching of executables on the system with the system rights that are equivalent to root rights on Windows, and every host, every asset that is linked to this Active Directory will be able to launch your executable. So you will have to design this group policy object, this GPO, and in order to design it, you will have to elect a collector type. For example, if you want to target recent versions of Windows, or maybe older versions, and you will have to give it also the configuration file alongside with the executable, so that they can be launched on the assets of the information system. For now, the only tool that we will provide is a tool that allows you that assists you in writing the GPO, but you will still have to interact with your Active Directory to install the GPO and configure it so that no other person than the domain administrators can modify them. Also, yes, the API of the centralizer is also written in Flask, Python 3, SQL Alchemy, also with front-end in React.js. Then, one of the most important things that your tool will do, that CERTitude will do, is collecting data. So this is what will be launched on the assets of your information system, and let's see how it will be launched. So as I said, on Windows, you have the advantage of having your assets that are linked to the Active Directory. So you will be able to use the GPO to launch your executable. So as I said, the executable will be launched using the system rights, which are the best rights you can have on a Windows system. On Linux, there is no such decentralized centralized administration thing. So either you can launch manually the collector as root, or you can use maybe interface with a pre-existing agent on the Linux infrastructure, for example, the Puppet. Now, regardless of the exploitation system, the operating system, when you launch a collector, the collector will declare itself to the API. Will say, hello, I'm here, I'm starting the collection of things. So the API will give him a GUID, and it will start tracking the evolution of this collector. Then the collector will collect some basic information about the operating system. For example, the IP address, the host name, the version and the type of operating system, just to give some more information to the API. And that way, the API will be able to track better the collection status on the hosts. And finally, once this is done, the collectors will launch in threads all the collection modules that will be here to collect and gather data about the system. So, for example, the list of processes, the list of registry keys, the services, the open connections, the destination trees, etc. So about this collection modules. So collection modules are written in Python 3 or Python 2. We can't currently compile Python 3 or embed it with PyInstaller for Windows XP. This is not supported, not with the modules that we want. So we have to keep a branch of Python 2 just to this outdated OS, but which are still used within companies. So we have collectors for every type of OS, recent Windows, legacy Windows, and Linux hosts. And the advantage of these collectors is that they are multi-threaded. So basically, every type of information is searched for in parallel. And the other advantage is that when you write this very sensitive data to the disk, you never write it in clear text, but it's always compressed and encrypted before touching the disk. So that is a nice prerequisite that we wanted the tool to have, and I will dive into it later. So what does it look for now? If you wanted to, for example, launch the collection module by yourself on a host, so you have an exe file that is configured with a JSON configuration file. You launch it, and you can see that the first thing that it does, it's contacting the API to get a GUID. And then it's collecting information about the OS, and in that case, it's running two collection modules, which are the process and registry collection modules. Once you have launched the collection module, you can start tracking it on the API side, on the centralizer node side, and you can see the evolution of all your collection on all your hosts. And you will see, for example, the host on which the collection modules have failed, etc. So this is a great thing to have to monitor the evolution. Then, once you have gathered the collection results, and in fact, as soon as the first result arrives on the centralizer node, there is the analysis engine that kicks in and that starts analyzing the results the collection results that you have in regard with the elementary indicator of compromise that you have. So they will match, okay, this is a process, I have collected process data, I will try to match them and to obtain a match that it will be able to report back to the master node. So basically that is what it does, and users can log in on the centralizer nodes to see the progress of the analysis, and they will be able to export the analysis results back to the master node so that they can see a global visualization of every host that may be compromised with the current attack profile. I will dive into this later, but we have set in place some public key cryptography on every node so that all the all the communication between all the nodes are signed, encrypted, secure, and things like this, so that no results can get forged by an attacker. Basically, what are the prerequisites of launching this tool? We had before an old version of this tool which was horrible to launch on the information system because there were lots and lots of prerequisites. This time it's quite easy. The first thing you need is global. We rely on group policy objects, so we will have to have access to an account that can create group policy objects, or the client will need to configure this group policy object. So basically, give access to a temporary domain administrator account so that we can configure the tool. Next, it's about communication, mainly communication between the assets in the information system and the centralizer nodes. What you need is to be able to have an HTTPS stream between them in the assets to centralizer way. So this is quite configurable. You can configure it on any port that you want. You can even use a proxy between them if you want. This is things that we integrate in CERTitude. And finally, we need servers and we need storage. The goal of the centralizer nodes, it's not something that you bring with you. It's something that you build with the client on the information system. So basically, if the client has an hypervisor, he can use it to pop some servers and add lots of storage to be able to collect all the information about the assets in the information system. By designing the tool this way, there are some plus sides that we have in comparison to other collection methods. And if you didn't use a tool, for example, the first one, obviously, is that it's automated. So it's quite faster than analyzing every host by hand. But also, we have this great thing that is in the slide. We wanted to ensure confidentiality all the way from the master node to the assets in the information system. And basically, our tool respects two standards. The first one is that when you are in an investigation case, you most likely don't want the attacker to know what you are searching for on the information system. You don't want him to be able to adapt to what you are searching for and to miss him on the information system. So basically, you want to hide from the assets and you want to hide from an eavesdropper on the network. And in other cases, you are in a sensitive information system, and you will need to, in this information system, you won't have the right to just collect the data and take the data to your premises to analyze them. So you will need to perform the analysis on the client's premises, and this is what we do. So if you look at the picture that we have behind, you will see that our indicator of compromise by all that I explained to you before, our indicator of compromise never go further than the centralizer nodes. They are designed on the master nodes. They are given to the centralizer nodes, but they are never disclosed to the assets on the information system. So you keep. Since you just have built the centralizer nodes, they are safe, they are hardened, so this is okay. And the client's potentially sensitive data will be collected on the assets. They will be stored on the centralizer servers, but the centralizer servers are part of the information system of your clients. They are hardened, so they are not compromised, but the data will stay there. And the only thing that will leave the centralizer servers for the master servers are the analysis results, so the data that has been analyzed and just the detection match. So basically, all the data stays within the information system of your clients. There are two more things that are quite nice about this tool. The first one, we decided to call it the DAT mystery. When you have to interact between the master nodes, the centralizer nodes, in some cases they won't be able to talk to each other because the information system is very segregated and things and extra. So you will need to transfer information from one to another without using the network. So we used what we call the DAT files. We have four types of DAT files for now. We have the user, the node, the IOC, and the results. And basically, these DAT files are files with JSON data that is extracted straight from the database into the DAT file and imported into the database. And there should be no problem about that. Wrong. If we do that, anybody can usurp our data, can usurp result data, node data, etc. So what we need is security behind these files. And so we decided to implement some kind of public key cryptography in our tool. So we rely on standard RSA and things like this. And so basically we generate a key pair. One key pair for the master node and one key pair for each centralizer node, and we use this key pair to sign the data that we send from one node to another, and we use also the same key pairs that we have produced on the centralizer to encrypt the data that is collected from the assets and sent back to the API on the centralizer. So this is how we can ensure that the data that we collect on the assets never touches the disk in clear text mode. They are already encrypted and unavailable to an attacker that is listening on the system. And how do we do this? We have designed our own crypto library that relies on standard crypto algorithm and ciphers. Basically, this is a crypto API that our programs can use to read and write a file as if they were in clear text. But in the meanwhile, there is always a compression step of the file so that it takes less place. For example, when you want to extract the registry hives of a whole system, this can take up to 100 megabytes, and you want it compressed to take less size. And then before it touches the disk, this is encrypted. So we use two state-of-the-art cryptographic principles to have it encrypted and compressed before it touches the disk. And then the file is sent to the API, and the API does it kind of the reverse way. The API will use its private key to decipher the file and read the content and analyze it with the indicator of compromise. So that's it for the operating of CERTitude. We wanted to share with you a little bit of our future roadmap. So we have a short-term roadmap. So as Vincent said, we have had our hands quite full with investigations during the late few months. So we still need to complete that release before we can share it with you. So what will be included in this short term? So before the end of the year, we will complete the first version of the analysis engine, so that it will be able to do all the things that we just talked about. We will include a nice visualization dashboard on the master node that you will be able to use to really explore the data that is matched. For example, we have noticed that nowadays indicator of compromise don't carry the same data. Some are very useful, some are not, especially if you split them. For example, some will be, okay, a service is running, and some will be, okay, the file hash is, and then followed by hash. So some of them are really useful and can be used to filter data and to match things from the collected data. And some of them will just be bonus to filter more your data. So that is what we call the primary and secondary IOC. And then what we want is also to keep developing more collection modules about the tool, so that we can at least match our collection capabilities with the previous versions of the tools, and then always increase it to be able to match more and more attacks on the fly. And then we have a more medium to long-term roadmap. So we would like to be, in the future, to be able to implement a kind of explorer of collected data on each centralizer node. For example, in some cases, you find more indicator of compromise on the IS, and you know it only targets 2 to 3 workstations, and you have already collected the relevant data, but you don't want to analyze it all the way again with all the indicator of compromise. So what you would like is to get on the centralizer node and then just to explore the process, the services, to get some information about that. Of course, Yara is kind of trendy right now, so we would like to also have a dedicated Yara collector so that we can use it and find Yara matches on the host. The only thing bad about Yara is that if you launch it on a live system, you will disclose what you are searching for to a potential attacker on the file system. So this goes with the final points. Also, maybe in a distant future, we'll be able to analyze an offline image of a system, or maybe even a memory snapshot of the system to collect process list, service list, etc. And of course, we are really open to ideas that you may have about the tool. So we hope that you liked our presentation that differed a bit from Suricata. But if you have questions to ask us about, now is the time. We hope to be able to release the final version of the tool, so the V3 release before the end of the year, once we have completed everything. So if you have questions about the tool, feel free, and we will be here else until Friday, so you will be able to talk to us. So does anybody have a question? Thank you.